Put the equation 9y squared minus x squared minus 6x equals 10 into standard form. Then we'll find the center, vertices, foci, and the equations of the asymptotes. We need to complete the square anytime we've got something where we do not have a perfect square. So we've got our 9y squared, that's fine because there's no other y terms. But then we've got these x terms. So first I'm going to go ahead and factor the negative out. And we've got x squared plus 6x. And then I can complete the square. So that's x plus half of this number, 3 squared. And this is an extra 3, this gives us an extra 3 squared times a negative 1. So this gives us an extra negative 9. And so we're going to put another negative 9 on the right side as well to balance that equation out. Well, that's equal to 1 now, which is fantastic, because that's the standard equation for a hyperbola. And so now this is in our general form. The 9 right there is kind of weird because we're used to y squared over something, so I'm going to write that as over 1/9. And then minus we'll write the x term as well as x plus 3 squared over 1. And then finally, we can write both of these as something squared. So we've got y squared over 1/3 squared, and then minus the x term over 1 squared. All right, now we can start to find all of these features. So our center is at -3, 0. Because the y is coming first, this is a vertical hyperbola. So for our vertices, we have our center, but we'll move in the vertical direction. So we'll have our -3 and then 0 plus or minus the y number, which is 1/3. For the foci, we need to find c. So for c, we have c squared equals a squared plus b squared, which is 1 plus 1/9, or 10/9. So c is root 10 over 3. So for our foci, again, it's the same form. We take the x coordinate of the center and then plus or minus c, which is root 10 over. For the equations of the asymptotes, we're going to use, we know that both of our asymptotes go through this point, the center. And we know that the slopes are plus or minus b over a. So let me go write this. Slope is plus or minus, b is 1/3, over a, which is 1. Okay. So our slopes are plus or minus 1/3. And we know that they both go through the point -3, 0. So we can use point slope form of a line to get the equations. Point slope form of a line is y minus y naught equals m times x minus x. So we can go ahead and plug in the point and the slope there. And I'm just going to do this all together in one thing. So y minus y coordinate is 0 equals, the slope is plus or minus 1/3 times x minus the x coordinate, so plus 3. So we have y equals, and if I go and distribute that, plus or minus 1/3 x, and then plus or minus 1/3 times 3 is plus or minus 1. Okay. You can write them as separate things if you want. Take the positive through that, or take the negative through, and then have those two separate equations. Doesn't really matter. Or, of course, you could just leave it in this form that's already factored. So those are the equations of our asymptote. Okay, we've got all of these things that we've asked for, and now we can graph the hyperbola. So we've got our center. Our center was at -3, 0. So -1, 2, 3, 0. There's our center. We can create our box, which goes 1/3 in the y direction, so not very far at all. And 1 in the x direction. So very small box there. And then create our asymptotes. Notice that we can be a little bit more precise with our asymptotes because we know we have got y-intercepts of plus or minus 1. Okay, so that helps us to graph them a little bit better. And this was a vertical hyperbola, and so we draw this vertically. There are vertices, and follow those. Oh, that was sloppy. Follow those asymptotes. And of course, we could draw the foci as well, okay, which are pretty far away, okay, plus or minus. Oh, actually, sorry, root 10 is a little bit bigger than 3, but that's divided by 3, so it's just a little bit bigger than 1. Not that far. And there's our hyperbola.